Why is life on Earth carbon-based? Have you ever wondered why every living thing on Earth is a carbon-based organism, and if other forms of life could exist somewhere out in the universe? From 1869? When Mandela first created the periodic table, striking fear into the hearts of high school students everywhere, to today, the family of elements has grown to 118 members. Everything we see is built from these elements. Among them, the four most fundamental and common are hydrogen, carbon, nitrogen, and oxygen. But one element reigns supreme over all life on Earth: carbon. Why did life on Earth choose carbon and not another element? In the microscopic world, an atom's stability primarily depends on the number of electrons in its outermost shell. By sharing these electrons to form covalent bonds, atoms can link together to create molecules. A carbon atom can form 4 of these bonds, and when they combine in 3-dimensional structures, they can create an infinite variety of carbon backbones. This makes it the element with the most diverse range of compounds. Not only that, carbon possesses a unique combination of complexity and stability, providing the rich material foundation for carbon-based organisms to form. Nature used this miraculous element as the framework to build our vibrant and dazzling world of life. That process is the grand saga of evolution on Earth, and it's the only way nature chose to create life as we know it. In the Earth's crust, carbon is only the 15th most abundant element, but in the universe as a whole, it is the 4th most common, after hydrogen, helium, and oxygen. This cosmic abundance was a crucial condition for life on Earth to choose it. But still, beyond Earth, could there be life forms based on other elements? As far back as 1891, the German astrophysicist Julius Scheiner posed this very question at a seminar. Could silicon-based life exist in the universe? This question sparked an endless debate in science and science fiction: the silicon organism. By 1893, British chemist James Emerson Reynolds fully endorsed this view, pointing out the possibility of silicon-based life. Because silicon and carbon belong to the same group of elements, they share similar fundamental chemical properties. For example, carbon can combine with 4 hydrogen atoms to create methane, and silicon can do the same to form silane. Therefore, it's highly plausible that in the vastness of the universe, silicon could also form the organic compounds necessary for life. However, skeptics point out that a silicon atom has 1 more electron shell than a carbon atom. This means its control over its 4 outer electrons is much weaker, making silicon-based compounds incredibly unstable. Furthermore, silicon is over 1,000 times more abundant than carbon on Earth. If silicon-based life were truly viable, it, not carbon-based life, should be the dominant form on our planet today. On this point, Carl Sagan argued that the belief that life must be carbon-based might be a form of carbon chauvinism. Limiting our imagination and our search for extraterrestrial life, the universe is far stranger than we can perceive. And perhaps, in a place we've never imagined, a peaceful group of impossible silicon organisms exists. Astrophysicist Victor Stenger took this idea even further, suggesting that the very assumption that life must be made of molecules could be a mistake. In other universes with different physical laws, atomic nuclei or other structures could combine in bizarre ways beyond our wildest imagination, creating life forms that defy our current understanding. In other words, carbon-based life isn't necessarily the only kind of life in the universe. But if silicon-based life did exist, how different would it be from us? In an oxygen-rich environment, when carbon is oxidized during respiration, it forms carbon dioxide, a gas that is easily expelled from the body. When silicon is oxidized, it forms silicon dioxide, SiOs, a solid material like quartz or sand. This would pose a major obstacle for the respiratory system of a silicon organism, less of course. They lived on a planet with temperatures high enough to turn solid silicon dioxide into a liquid or gas, allowing them to breathe like life on Earth. Some silicon compounds are incredibly heat-stable. For instance, the silicon-oxygen bond can withstand temperatures of around 600 degrees Celsius. For a silicon-based organism, comfortable environment might be around 400 degrees Celsius. On a temperate planet like Earth, they would likely freeze to death. Even the appearance of silicon life would be vastly different from carbon life. Most researchers believe that if silicon organisms exist, They would likely resemble sentient, mobile crystals, though we have many theories about the chemistry of non-carbon life. They are ultimately just extensions of our understanding of carbon-based chemistry, according to the logic of the Fermi paradox. The reason we have and found aliens might be due to the vast differences in life forms shaped by their unique environments. And because we lack the proper methods to recognize them, the universe appears eerily silent. Let's assume the dominant form of life in the universe isn't carbon-based, but something entirely alien to humanity. In that case, perhaps two other forms of life, we are the ones who are undetectable and incomprehensible.